Hello, everybody. Thank you for joining us here today. We have two engineers from NuoDB who are going to share their elastic, scalable SQL database built for the cloud and how it runs on your Google Compute Engine. So to quickly introduce myself, I'm Brian Dorsey. I'm a developer engineer on Google Compute Engine.
I'm Seth Proctor. I'm a core engineer and architect on NuoDB.
And my name is Tommy Riley, and I'm also an engineer on the NuoDB product.
Fantastic. Thank you for coming out, guys.
Thanks for having us here.
And
Yep.
I think we're going to jump straight to demo. We're not.
Sweet.
We're going to jump straight to NuoDB. What is NuoDB?
NuoDB is a brand new relational database that is designed to be cloud scale. And I think most people know what we mean when we say it's a relational database. It's something that is ACID, it's something that speaks SQL, it has JDBC and ODBC drivers, it works with kind of the standard ecosystem of tools that you expect to see out there. It's the cloud scale part, obviously, that's interesting and exciting, and that's why we're here today. And cloud scale can mean many different things to many different people. We're going to show a couple specific pieces of that today. And what we're really going to show is that we are a relational database that can scale out the way people want to scale out infrastructure. So you can start developing on a laptop, and as you need more resources, you can add a few more machines, and then obviously as you need more resources, you can do something like take it to Google Compute Engine and really scale massively. And it's designed to do all the other things you want in a cloud scale environment in terms of security, in terms of resource management, in terms of ease of use, multi-tenancy, all kinds of other great features that you really want in a cloud.
And to be clear, it's a real SQL database.
It's a real SQL database, and we'll talk about that later. But yeah,
Fantastic.
it's a true SQL database, but it really scales the way kind of no SQL or sharded systems work, but with no sharding, no partitioning, very easy to work with. We're pretty excited about it. We think it's pretty cool.
100% ACID.
Fantastic. Well, let's see what that looks like.
All right, let's see what this looks like. First, Seth is going to unlock the screen for us. Thank you, Seth. And you should be looking at the YCSB demonstrator that we've created. CDMS is a term that we've come up with. Apologize if the font's a little small, but you'll be able to see the graph, I think, which is the big thing. So I'm going to kick off this demo, and then I'll talk about what's going on while it's running. But this is the Yahoo Cloud serving benchmark. And what it is let's wait for it to get running here, make sure it comes up. And hit start. Seem to be having some technical issues. Bear with me for a second.
So basically what we're looking at here is we took the standard YCSB benchmark that's used to demonstrate kind of common web scale applications. And we wrapped a kind of a nice UI around it to demonstrate how you can start with a single machine and you can start adding more resources as you need them to scale out.
So this is a visualization on top of the existing benchmark.
That's right. That's exactly right. So this is exactly just the standard YCSB benchmark. We haven't done anything to it. We haven't, done any of the fun tricks to make it work, particularly well for us by tweaking something in it. We just took the vanilla benchmark.
Right.
But what we're doing is we're starting with a cold environment, and that's kind of why Tommy's tweaking something right now. Is we're starting with a cold environment, and we're bringing things online. We're bringing them online in the Google environment.
Gotcha. So when you're evaluating infrastructure to run NuoDB on, what kind of infrastructure do you look for? Like, what makes NuoDB run really well?
That's a great question. I mean, so I said earlier that NuoDB is a product that's designed to be cloud scale, right? And so part of that means that you have to understand that failures happen in a cloud. And you have to understand that systems go down unexpectedly, networks fail unexpectedly, even when things are up and available, you get inconsistent network spikes, dips, you get all kinds of weird, crazy things happening in clouds that you don't expect. And so being cloud scale isn't just about being able to scale out, it's about being resilient to those failures and, when possible, trying to stay ahead of them. So in theory, we are designed to work with any kind of commodity hardware, any kind of commodity networks. We're very good at working with unpredictable environments, but anything that has better network capabilities, has smoother network capabilities, has higher CPU is obviously going to let any piece of software run better. And so that's part of what really appealed to us about our experience in Google, was an environment that really was a solid networked environment, a solid set of virtual machines. How are we doing, Tommy?
I think we're having some issues connecting. For some reason, my Linux laptop can't talk to the Google infrastructure, but I think I may have it reset. So we're going to try again.
It's good to go.
We apologize.
And what you're seeing,
describe what we're seeing here.
Yeah, so what Tommy's doing here, in part of what you're
Sorry.
seeing, the plus side of getting to see this kind of working live is that you're seeing that he's really right there live on Google Compute Engine. He's in there, and he's been using a number of different tools as he's trying to figure out what's going on. He's using the web interfaces, he's using the command line interfaces. One of the things that's really appealed to us about the Google Compute environment has been how easy it is to work with on the command line. Just the simple utility makes it really easy to get onto instances, to provision them, to set up firewalls, to kind of monitor what's happening. It's a really straightforward, really nicely streamlined way of just getting running with the environment, and then being able to run between like a Mac environment, a Linux environment, a Windows environment, just get running.
Everything works the same.
Everything just works the same. Yeah, and it's really easy. It's really nice to be able to see everything in one place. The documentation is just like super streamlined and just makes it a breeze to get up and running. I think from the first time I sat down and actually started playing with it to the time I was running was just a few minutes. So that was great. And it works really well with the NuoDB model we have, because part of what our software provides is not just the database, but it's all of the management and provisioning around the database. Being a cloud scale database means being easy to provision hosts, easy to get the software running, and so it's a really nice match between the provisioning and management model in GCE and the provisioning and management model that we have in NuoDB.
Awesome.
Seth, that was a wonderful job of covering it for me. Thank
Sweet.
you. We have the demo
And
running.
we're back.
We had some technical issues, but we have those resolved now. So we have the demo running here for you guys to see.
Let's do
So
it.
what I've done is I've started the YCSB client on one instance. We have 32 instances in the Google Cloud running, but we'll start with one. So the NuoDB database is provisioned across those, but right now I'm just running one of our database transaction engines and one YCSB client. You can see here with the little green icon, that's my GCE instance. And for this benchmark, which is the YCSB B workload, it's 5% updates, excuse me, and 95% reads. We're getting roughly, 50 to 60,000 transactions a second. So we have a button here which will start another transaction on the next instance, and then also start a client to hit that. So,
Right. So just to be clear, what's happened is, this is what we're talking about, the managing, right? Tommy has provisioned a number of hosts, but has only actually started a database process running on one of them. And so what he's going to do as this demo runs is he's going to start new processes that will come up cold, will automatically just start talking with the existing processes, and as that happens, you should see this graph scale.
right. So if we go back to the graph, we'll see that with two instances, we're running pretty much very linearly twice the number of transactions we were running with one. So that's kind of the point right there with NuoDB. There's a lot of databases that can't just make that one step from one machine to two machines. We made that step relatively quickly, and we've shown the scale. So I'm going to go ahead and crank it up to 4 now and demonstrate some other things I'd like to show you guys. Interacting with the Google Compute Engine and the NuoDB process is very similar. Google Compute Engine has this nice command line tool, nice little Python tool that allows you to see all your instances. So here I've listed all our instances. It has 32 instances of our database, and I'll show the web UI as well. But then, not to be outdone, NuoDB also has a command line tool. And now here I'm showing, hopefully the font's big enough once again, all of our agents are provisioned. Our agents are just management agents that don't actually run the database, but they control starting and stopping it and monitoring. And then down below, you'll see that we have 4 transaction engines running on 4 different hosts, and then 1 storage manager that holds the actual disk. So that's the command line tool. And then I'm going to switch back.
And these are the 4 instances we should be seeing the graph on right now, right?
Yeah, so we're looking at the graph now, and you'll see we had step 1 was, like 60,000 or so. We went to step 2, where we got up to 120. Now we're at now we have 4 instances, and we're up to 250. So we'll go ahead
Excellent.
and
Just keep cranking
we'll
it
go
up.
to crank to 8.
Yeah.
We're developers, so we're big fans of powers of 2. So we're going to go to 8 next. And then also,
To be clear, there's nothing in our system that's optimized for powers of 2. It's just that we, no matter how the system is built, we still can't get away from talking
Seth,
about like 2, 4, 8, like.
Sure, there are things optimized for powers of 2, just not numbers of hosts. So this is the graphical administration tool that allows you to see, get some pretty graphs about stats and stuff. But this is one logical database, like as we mentioned before, and this is going to show which processes are involved in serving this logical database.
Just use the
Because of font issues, we can't really scale, but if I do my little finger magic here, you should see the instances that are running. You'll see up here that 9 processes are running. Again, that's the 8 transaction engines and 1 storage manager.
Right, and Tommy just said something really important, right, which is that what's really nice about this model is that there are all these different processes running. They can be running on different hosts. They can fail. They can come up. They can come down. But from the point of view of the developer, from the point of view of the application, there's a single logical database.
Okay.
Right, so there really is one database we're addressing. The fact that these processes are being added, the clients have no idea about that. They just know there's a
So
database
as
they can
a developer,
address.
I don't need to know at
Right,
all
right.
what's going on.
That's right, and that means we can bring things down live. We can migrate live processes. We can actually have 100% availability while we're doing upgrades or while we're doing migration, and it still just looks like a single live database, which is really cool.
So here's a slide I just wanted to show. Just going to drive home this point further about what we're demonstrating. This shows the kind of a rough diagram model of what's running. So we have each of these boxes represents a Google Cloud instance, Google Compute Engine instance, sorry. So in each box, you'll see a YCSB client running, there's an agent running, which is NuoDB's agent, and then a transaction engine. And then we've done a little dotted line here to show that this is one logical database engine. So, that means, that if, NuoDB instance 32 tries to update a record, and NuoDB instance 1 tries to update a record, only one of those transactions is going to proceed. Like these nodes are talking to each other and making the semantics of
So
asset
you need the network to
compliance.
work well.
Yes, network working well helps a lot.
We ready to keep going?
All right, so we're
Yeah.
running along nicely with 8. Should we go to 16?
Can we jump straight to 32?
We probably could. We have to wait. It's
We
it's
actually-
starting each transaction engine serially, so it'll take a couple seconds for all 8 to come up.
You actually can start as many as you want on top of each other. The UI we have here was designed. You can see the pause play buttons. This was designed as a thing to help someone kind of step through and understand what they're doing. So
Sorry to
the
jump
UI
ahead.
the UI itself doesn't let you do it. The software lets you do it.
Gotcha.
All right, so we're almost done starting up those 16 instances. The additional 8, sorry. And you can see that we're approaching
1 million.
1 million TPS we're approaching.
Fantastic.
We're not quite there yet. But all right, so now we have the engines running. The numbers are still upgrading, it's fluctuating a little bit. But in the interest of time, we will jump right to 32.
Fantastic.
And the important thing, so there's the big curve that we're looking at, right, which is that big blue curve, and that's the transactions per second, and that's obviously really exciting. Down in the lower left corner, there's another curve which is also pretty cool, which is showing latency. And that's showing that even as we're going from 2 to 4 to 16 to 32 hosts that are expanding out this database, we're still hitting sub-millisecond latency on these requests.
Excellent.
And so it's not just about that scale out. We're still very responsive to all these queries, and that's, for a lot of people, that's just as important as the raw throughput, right?
Absolutely.
Oh, Tommy, look.
Yep, we're getting there. We are still in the process of rolling up these, bringing online the additional 16.
So if I wanted to do this, is there information on how to get started?
Yes, so we have written a blog entry, and we have a link that we'll show at the end here, but on NuoDB.com we have a tech blog, and we wrote a blog entry describing kind of the nuts and bolts of what we went through and how we did it, and we hope to be publishing some assets from that to make available to developers, and definitely recommend people check that out.
Right. And so what's really cool here, in case people are missing this number, is that we just went in a few minutes from having a cold environment to just bringing hosts online to get up above 1.6 million transactions a second on what is a fairly representative workload. And that's cool on its own. It's also really cool because we're doing this on a virtual public cloud environment. And we've been able to hit these kinds of numbers on our own internal systems, but to hit them on something like Google Compute Engine is just awesome.
Fantastic. Say that number again.
We're up to 1.7 if you look at the graph.
1.7 million
1.7 million transactions
Per
a
second.
Per second, yeah.
Fantastic.
Which is, we think, pretty respectable.
So ending up at this kind of number, like what sort of performance testing do you guys do to evaluate the environments?
You know what
is
we
it
do?
This sort of thing?
We use this sort of thing, right? So one of the things we look for in a test like this is, if you start up 8 nodes, you look at the latencies. What's the standard deviation? Like, are the latencies nice? It's good to have a nice low average. We're showing the average here in this graph, of under a millisecond. But are there any outliers, that kind of thing? So is node 32 really slow? What's the full connectivity? We look at we use some off-the-shelf tools like iPerf, to measure the bandwidth. And you can measure disk throughput with some simple utilities. We do stuff like that. But and generally, we're just looking for nice, consistent disk I/O and network I/O.
And part of the reason we've created demos like this is because fundamentally the architecture of NuoDB is radically different than most relational database architectures. So it's very hard to just take an off-the-shelf benchmark or suite and say this tells us how something performs in a scale-out environment like Google. And so this is a fairly simple demo we're showing, but it is the kind of thing that we can say once we get those raw numbers, what does the I/O look like, what does the network look like, what does provisioning time look like, then being able to take something like this and say, well, realistically, can we hit, we just hit 1.8 million transactions a second, so this is, to us, this is really exciting, and this is really how we do it, so we have to take real pragmatic applications and say, well, can we make that application or that representative workload scale,
and the application didn't have to change. This is off-the-shelf JDBC, simple, using prepared statements to execute these queries. You can see we're getting sub-millisecond latency times. If your application is just simple JDBC and getting those, kind of times, you really don't need to add memcache to get the kind of low latency.
Just go directly to the database.
Right. The transaction engines kind of replace that, and your application's going to remain simple. Simpler as a result.
Right, that's a very important point. NuoDB is, among other things, its own caching architecture. And so the transactions are all running on in-memory processes. That's very powerful in terms of failure. That's very powerful in terms of how easy it is to provision new hosts. But it also means that there's no need, and in fact, you shouldn't be thinking about adding additional caching tiers or any kind of other tiers on top of that to optimize the system. We're already taking care of that for you, which is part of the easy out-of-the-box experience that we're trying to provide.
Totally. And you touched on this a little bit earlier, but it seems like this was a fair amount of effort to get this up and running. How did you find getting started, on Compute Engine?
It's easy.
Yeah, it was fairly easy. Linux is a very, one of our main supported environments. We got up there, and it was a nice, easy selection of kernels to use. Just could have picked any one of them. Deploying and installing it was a breeze. That's one of the things covered in our blog. The GC util, had a nice high-level a layer of abstraction for the things we needed to do, provisioning the disks, getting the firewalls set up. All that was relatively straightforward.
Fantastic. Actually, can we show that the link to your blog?
Sure, it's up there. Yep.
Yeah, so this is a new thing we've started doing in the last few weeks. We're trying to get our engineers talking directly to people who are interested in the technology. So this is meant to be a very cut to the chase, pragmatic, how you do things, how the technology works. We really encourage people to go check it out, to give us suggestions of what they'd like to learn about the product. And then we're also going to be collecting information kind of more specific to our Google Compute Engine experience. And as we generate more benchmarks, as we generate kind of more experience there, we'll be posting links there for people to find it.
Fantastic.
Our blog post on Google Compute Engine was live as of this morning, so you can be the first person to comment on it if you
Excellent.
Check it out.
The live audience is the very first people to
Definitely.
see it. Fantastic. So you said before this is the full relational SQL database, but from what I understand, the YCSB benchmark is really kind of more of a key value benchmark.
Yeah, so we've got a little bit more time, and we'll get Tommy to show you one other thing here, which is that we actually ported Jira to run on top of our database. And for those of you who haven't seen Jira, it's a very popular, very powerful issue tracking, project management, bug tracking system. And so we actually run it internally. We run our Jira instance on NuoDB.
Okay.
It was only a few hundred lines of code to get that going, and most of that was just kind of writing the standard adapters that they expect. So it was really a pretty easy out-of-the-box experience. And what we have here is actually an instance running on Google Compute Engine.
You should see the results. This is a frozen, older version of the actual NuoDB production bug base. So I can log in and see a bug. Reopen an issue that might have been closed. I'll assign that to my boss, and it will be saved. And this is running on the Google Cloud. We took the snapshot and we just deployed it. And it was literally like one morning we got this running and it's done.
And if anyone's used Jira anyone's had to deploy Jira, they know that there's a lot of SQL that just happened under the covers when we did
to make that all work.
Yeah.
So real database.
Real database, yeah.
Any last comments you guys would like to make?
No, just this has been an awesome experience working with Google. NuoDB is this really different architecture. It scales out. It really can take advantage of compute resources. It's really easy to work with, but it needs something that in turn is an easy provisionable environment, and that's been our experience in Google. It's just that's just awesome. So we look forward to continuing to work on that, and we'll be publishing more as we go along. And we encourage other people to check it out. It's great. Go try NuoDB on Google Compute Engine. It'll be a good experience.
Yes, I can't say it any better. That was
fantastic.
my thoughts exactly.
So Seth and Tommy, thank you both for coming in.
Great. Thanks for having us.
Thank
here.
you all for watching.